So welcome to 24 Hours of PaaS Evolution of the Data Platform. We're excited you could join us today for Rick Heiges session, Winning with Columstore in SQL Server 2016, a customer story. This is a 24 Hours of PaaS event, consists of 24 consecutive live webcasts delivered by expert speakers from PaaS community. The session will be recorded and posted online after the event. To access any on-demand session, please visit 24hoursofpaas.com. My name is Murilo Miranda, and I will be moderating this session. I have a few introductory slides before I hand over to Rick. Okay. If you require technical assistance, please type your question into the question pane located on the right side of your screen, and someone will assist you. This question pane is also where you may ask any questions throughout the presentation. Feel free to enter your questions at any time, and once we get to the Q&A portion of the session, I read your questions aloud to the speaker. You are able to zoom in on all presentation content by using the zoom button located on the top of the presentation window. Please note that there will be a short evaluation at the end of the session. Your feedback is important to us, so please take a moment to complete it. It will appear in your web browser. Next slide, please. Yeah. Okay. I would like to take a moment to thank our presenting sponsors, Microsoft, Amazon Web Services, Hortonworks, and Redgate. In addition, I would like to thank the supporting sponsors for this event, Hewlett-Packard Enterprise, SQL Central, and SanDisk. The stage of 24 Hours of PaaS would not be possible without the general support, and they are the reason this event is available free of charge. Next slide.
It's moving.
Oh, okay. Okay, so make sure you explore everything else PaaS has to offer for data professionals. You can join local user groups around the world. Special interest groups find free online resources through our Learning Center and read up on the latest community news in the Connector newsletter. Okay, next.
Yep, there it is.
Oh, okay. This session is presented by Rick Heiges. You can see him on the screen, also showing his face in the webcam, which is great for us. Rick is Data Platform MVP since 2007. He's involved with PaaS since 2001 and was a member of the Board of Directors between 2003 and 2011. He's initiated the 24 Hours of PaaS, which is very nice. So you can see he's presenting here today. You can find him. You have his email here. He's a principal solutions architect at the Best Technologies, and here's the email to contact him. Also, his blog, LinkedIn, and Twitter, in case you want to contact him. So now I will hand over to Rick. So good luck, and let's go ahead.
Great. Thank you, Murilo, for that kind introduction. And thank you for attending this session. And before we actually dive into the session, just want to kind of do a level set of what to expect during this session. This is not going to be a deep technical session with lots of demos. Essentially, it is a story, as the title indicates, about how we went through some of the decisions that we'll learn some of the whys we did what we did, and we had a very small, short period of time to execute upon this. We're going to see how the magic of the Columstore really made its debut here. And so really where we were with the customer, with any time you want to do a migration from one data platform for another one, you use the SQL Server Migration Assistant. And this was originally developed by DBBest. Microsoft acquired it in 2005. DBBest maintains the code, etc. But one thing what happens whenever you do a migration from Oracle to SQL Server, there's this extension pack, and essentially it's a helper schema, if you will, that's put into the database. And it's put there to reduce the amount of changes that you need. For example, there's an emulator in there for certain Oracle functions and calls and things of that nature. So the goal is to get the code converted as easily as possible, and it focuses on functionality and not performance. So right away, if you just take your code, like for example, if you have a cursor in Oracle, it's going to convert that into a cursor for SQL Server. So really, you're kind of starting out as a handicap right off the bat. So I want to tell you about this customer. There's a major manufacturer. They have plants all over the world, and at their assembly lines, they take measurements with precision instruments so that they can improve upon quality of their products. And all these measurements are captured and they're stored into a centralized data warehouse. And this just happens all the time because the plants are 24/7, and the data is flowing in all the time. And the managers at these plants and other analysts generate reports and do analytics on that data, and they might slice it down to the hour or maybe the shift, day, week, whatever time period they want is what they're really focusing on. And often they're reporting on the data that just was sent from their plant to the centralized data warehouse. So that's kind of what their business scenario is. So I have a little graphic here. Hopefully this will help relay that story to you. Plants feeding data into a data warehouse and a plant manager getting reports out of it. So they were starting to get some issues with scaling. Some of their queries and analytics were taking a pretty long time to execute on. So they contacted Oracle, because of course it's an Oracle data warehouse, and Oracle said, we have this new feature called our in-memory feature. And essentially what it is as if you took a partition table and you took one of those partitions and you pinned it into memory, and that's the partition that gets all the new data that's coming in. And from the sound of it, I was like, oh, wow, that should solve a lot of problems. But in this case, it didn't. Actually, performance was decreased when they turned this on. So they turned that off, and then they said, you know what, they're moving lots of other stuff to SQL Server gradually, and so they said, let's take a look at maybe moving this one to SQL Server as well. So they contacted Microsoft, and they built a very small VM just to convert the schema over and just do a little bit of data transformation from Oracle over to SQL Server, just to do some real basic functional testing, make sure you can actually query the data and it looks like it's there. Then they started to identify the queries that are giving them poor performance on their production system. And also initially, when they brought over the schema, they basically just did what I call normal indexing. They put like a clustered index on the primary keys, and that's about it. And then we had about a 4-week time period in order to get a pilot off the ground to kind of see if Columstore is going to be the answer for them. So here are some environmental notes, right? They started out with a initial VM with 4 virtual CPUs and 8 gigs of RAM, and this was just to get this schema over and do a reality check on the data. And then I said, you know what? This is a data warehouse. You can't run a data warehouse on that small of a VM. And so they got me upgraded, or got the VM upgraded to 8 virtual CPUs and 32 gigs of RAM. Still not what I want, but at least it's something better. Got some elbow room to move around in. And then finally, for the eventual end testing, we got up, a bigger VM, still a VM, so not really what I want, but still better, 16 virtual CPUs and 256 gigs of RAM. And so, and picture this, we're going to be going up against their current dev test environment, which is on 2 nodes of a 4-node Oracle rack system. So it's on, big iron, 256 gigs of RAM per node. So it's really right off the bat, I'm thinking this is not a fair fight. But we're going to go see what we can do anyway. Then we started running into some challenges. When you're migrating from one data platform to another, you are going to come across some challenges. One of the things that this customer did is they relied heavily on partitioning that's available in Oracle, which is a little more advanced than what you have in SQL Server. For example, they have something called referential partitioning, which I would love SQL Server to get. And if you don't know what that is, I'll explain it real quick. That is, let's say you have an order header table. It might have like customer number, order number, of course, salesperson ID, and a date, right? That's in the header. And then you have an order details table, which has order number, maybe line number, item number, quantity, price, things of that nature. But you don't have date in there. But you want to partition both of these tables the same way and on that date. But there is no date in the details table. So in Oracle, you can implement what they call referential partitioning, and basically be able to partition both your header and your details on that same date in the header. I was saying, that's pretty cool. I want to become an Oracle DBA. I didn't say that really, but you know. Anyway, so that's going to be a little bit more difficult to implement whenever you look at what's available in SQL Server, which is just range partitioning. So we had that to deal with. We had to do some education around what you can do and what you can't do in SQL Server. Data type changes, some parameter data types, we had to change some of those to get some stuff to work. And again, the code that's converted is not focused on performance. So we're talking a little bit more about partitioning. One of the nice things you can do in Oracle is you can just say, hey, give me a new partition every week, and it will do it by itself. It has the smarts to do that. You really can't do that in SQL Server, so you can set up jobs, set up some scripts to run automatically to actually manage that for you. So it's a just something that you had to get some education on and to let the customer understand that you have to manage things differently when you from one data platform to another one. The other thing to think about is what to partition on. In SQL Server, dates is the big thing. It makes sense to partition on dates, especially in a data warehouse scenario. If you're going to be implementing Columstore indexes, there's another thing you want to make sure about, and that is that you don't make your partitions too small. And that's because if you partition too small, then you really can limit the impact of the tremendous compression you get, which really gives you great performance. So we'll talk about it's like 1,000,000 rows. If you want to make sure your partitioning strategy is over 1,000,000 rows, so you can really get that bump in impact for your compression in your row groups. So there are some things that we try to implement whenever I am working with a customer in migrating to SQL Server. We talk about audit reports, index is a big thing, and then also features. What new features can we use in SQL Server that we may not have in Oracle or other data platforms? So, first of all, I start off, okay, bare minimum a row count. If I have 10 million rows in the source system, I better have 10 million rows in my converted system as well. But just don't worry about row count. Also, get something that's of business critical value, like an amount, and do some stuff on there like min, max, averaging, to make sure that you come out with the same result so you don't lose any precision, and also gives you more confidence in your data that you converted everything successfully. So let's talk about indexes now. This slide and the next slide should not be a surprise to anybody. This is stuff that you should probably have already come across. And that is, well, first of all, if you just build a table without anything, it's called a heap. There's no physical organization whatsoever. It's just a structure there to hold data. Generally speaking, when you declare a primary key, that primary key has a clustered index built on it. And it's generally considered a best practice to have clustered indexes. As a matter of fact, in Azure SQL Database, I think by default, or I don't think you have the option to not have a clustered index in Azure SQL Database. So it's one of those things that's there. And of course, you need it for partitioning, And I always think about it as a page number in a book, right? So if, because it's physically ordered by page number in the book, and you just keep on, that's how you find things. So when you get to page number 28, and you go there. The other thing, which I'm not going to spend a lot of time on, fill factor, is how full you make your data pages to leave room. So when inserts do occur, that you don't have a page split and lead to more performance problems down the road. A non-clustered index, again, this is something you should have probably already come across if you've been working with SQL Server. And basically it aids in retrieval of data based on the primary key without knowing the primary key. We often use it for foreign keys or columns that are used often in criteria. We can also have something called include columns, which allows you to cover more queries. And I think of it as like the index in the back of a book. So I look in the index in the back of a book, look up frogs. It tells me frogs is on page 89. So then I go to my clustered index, my page number, and find that page and learn about the frogs that I was trying to find information about. So those are our traditional Rowstore indexes. And remember, when we're talking about Columstore, logically, they are still in rows and columns. The data is still logically, when you do a select from a table that's in a Rowstore versus a Columstore, when you see the results, it's the exact same thing that you think about. So we're going to talk about storage technology. So let's talk about what a Columstore is. And so we have data here stored as rows. And what happens is instead of going across, okay, we look down from the top of the table. And that way we can have things compress in a great way based on the domain of the data that's in. For example, if I have a column for state, here in the US we have 50 states, so you're going to have some pretty good compression on that column because there's only so many states that you can have, and it's a very small column, etc. So you have improved compression. And of course, when you have things that are compressed, when you read that data from the storage, it's going to be compressed to more efficient memory. Also, let's say if I have 60 columns in my fact table, but I'm only asking for data from 6 of those, automatically I'm ignoring 90% of the table. So I'm going to have a lot smaller amount of data I'm going to deal with, and with the data that I do read, it's going to be very much compressed and stays compressed in memory until I need to access that piece of data. So it's a great way to save space and therefore time. So just want to go over a couple of the key terms and concepts you might hear around when we talk about Columstore technology. And so I kind of refer to it as this way. It's a storage technology, right? It's really how things are stored, the physical format of it. So a Columstore and a Rowstore is the physical organization of how things are stored on disk. A row group is a set of rows that are compressed into the Columstore format, and usually, hopefully, in sets of the maximum number of rows in a row group, which is 1,048,576 rows. And so a column segment is a column of data within that row group. And so you can have different levels of compression depending on that data. Also associated with the clustered or with the Columstore is something called a Deltastore. And this is a clustered index or a row store where the data is stored until a minimum 102,400 rows is met, and once it reaches that threshold, it can move over into a Columstore. And this happens through something called the tuple mover. This is a background process that runs on a periodic basis, wakes up, says, do I have anything work to do? Yes, I need to go compress this. So it converts the rows in the Deltastore into the Columstore format. And there are ways you can get in there and adjust how often it runs and things of that nature. Also, batch execution is another term you may hear around Columstore technology. And basically, it works on sets of data, instead of individual rows. And you may have also heard this referred to as vector-based execution. So with these type of concepts and key terms in mind, let's look at this. And what I'll point out here is this is kind of a visual depiction of what a column store is. So we have a column store, and inside here we have two row groups. I have a particular row group highlighted here in green, and inside there are compressed column segments. So that's how it's stored. Now still, it looks like a table to you and me when we query it. Okay, no difference there. And then we have the Deltastore, which is again a normal table that we're used to seeing that's associated with this column store. So when we load data in to a column store, basically if we're doing a bulk load, it goes directly into the column store. But if we're doing like single and smaller loads of data, they first go into the Deltastore until they reach a certain threshold, and the tuple mover then moves it into the column store for us. So if you remember my business scenario about with this customer, so this is something you have to think about. They have data being constantly loaded, not like a fire hose, but not a trickle either. Somewhere, kind of a nice, even flow of data into the data warehouse, and so it's flowing into the Deltastore. So we need to think about performance there as well when we're doing our queries, and what indexes should we use on that fact table in order to get the best performance. So in 2012, the Columstore technology was launched in SQL Server. However, it made the table read-only, and it did some other things in 2014, but still a non-cluster Columstore index in 2012 and 2014. It was read-only, which meant you really had to use like the partition switch method in order to add data to that table, which again would not bode well for this particular customer with their particular scenario. But in 2016, the non-cluster Columstore index is now updatable, so it removes a lot of those issues that you had before. And also, you can only have one non-cluster Columstore index before. It was read-only. Now you can have multiple ones. And really, it complements the Rowstore. As a matter of fact, we were doing some testing at my company, and they did some testing with just a non-cluster Columstore index in 2016, and they saw really great performance on reads, as you would do with operational analytics, without much performance impact, as far as negative performance impact. It had really great results there. So just want to relay that experience to you there. In 2014, the clustered Columstore index was launched, and basically it converted your Rowstore into a column store. So there were no other indexes allowed in 2014 for a column store, but you had incredible compression, often up to 90%, and we had actually, I think, a little better than 90% with this customer when we did that. And you can also have a non-clustered index on top of a clustered index. So you can have a Rowstore index on top of your clustered Columstore index. And actually, this is one of the things that we did with our fact table. We had our fact table as a clustered Columstore index in 2016, and we put a non-clustered index on top of that, a Rowstore non-clustered index, in order to have better performance on the seeks within the row group and also the Deltastore. And there's certain restrictions apply, of course, but as each revision comes out with 2016, a lot more of those limitations are removed. So basically, I said, what can I use with what? What type of index can I use with which one? And basically, you can use anything with anything. Across the top here, it's a physical organization. It's either going to be a heap, a clustered index, or a clustered Columstore index. One of those three ways is how your data is going to be physically organized. And then you can have your non-clustered index or a non-clustered Columstore index on top of any of those. The only thing I point out is I can't think of a business reason to have a non-clustered Columstore index on top of a clustered Columstore index. it doesn't make any sense. So I haven't even tried it out yet. I don't know if it's possible, but I can't think of a business reason to do that. So but basically, this is really great, gives us great flexibility and power when we're thinking about the best way to access data in our tables. Then we also go and check out, when we're at the customer site, we look at the configuration of SQL Server and the environment. We look at the trace flags. Some trace flags that I often implement, such as 1117, 1118, and 2371, are no longer needed because they are the default now. So it is something you just need to check off your list again. We look at tempdb, make sure it's set up right with the number of files and the growth rate and location. We do the same thing with the customer database to make sure that there's nothing crazy with their setup. We look at the memory settings. We look at weight stats before we do anything, and also do what I call a quiet baseline. So I know what the levels are when nothing's happening on the system. So when I look at performance counters after the fact, I have something to compare it again and figure out if I really need to worry about that counter or not. So those are some of the things that we do when we work with customers, and in this case, trying to get a pilot set up. We did have to, we made some changes on the database side. We had some parameter types that we changed in the .NET application to match the SQL Server data type. I'm going to go over more about the clustered indexes and all the indexes that we chose in here. But basically, we use a combination of clustered column store indexes, non-clustered column store indexes, regular indexing that you've used for a while, and we also chose certain tables that we wanted to keep partitioning on because of their size. And for those times when we couldn't get the exact partitioning to line up, like I mentioned before about referential partitioning, we had to basically assign an arbitrary boundary point in hopes that we would get to a place where we could have partition elimination if we needed it. So basically, the customer's data warehouse was similar to this. This is the exact kind of layout, but it's traditional star design. And we had our fact table, which was pretty wide at 450 columns, and about 400 of those, actually a little bit more than that, consisted of measurement data. We had a large dimension table A that had a lot of data in it. We had some other smaller tables around here. I tried to visualize. Some of these are wider, some of them are smaller, some are shorter, etc. But this fact table, when we first loaded the first year of data in, it had about 100 gigs of data uncompressed, and hundreds of millions of rows in this particular setup. So we did our initial load, and actually we did our initial load when we still only had 4 virtual CPUs and 8 gigs of RAM. But we quickly got that upgraded and got some elbow room. But we were able to load that data in actually rather quickly. And we loaded in a traditional Rowstore type of format. We did not actually implement the Columstore index until after we got the data in. So after we got it in, we converted it to a custom store index, and we rebuilt it and reorganized it. And basically, it got down to about 8 gigs of space. So over 100 gigs down to about 8 gigs. So that's better than 90% compression. And that's where the magic happens. And then the Oracle DBA team started running some queries on some of the data that we had loaded. And they were pretty happy with the results, which really gave me cause to be happy about the potential of the pilot running really well. And then we started to load additional years of data, 2014, 2013 data. These volumes weren't as big because they weren't doing as many measurements back then. So So this is also something we had to adjust with our partitioning type of strategy, because we wanted to make sure we had at least, you know, 1 million rows per partition. So we went from a 1-week window to a 2-week window for our data to make sure we got over 1 million rows in a particular partition, which meant more than 1 million rows per row group, which gave us the great compression. Some of the other tables, some of the smaller dimensional tables, we basically just had a clustered index on the key. A couple of them we had some additional non-clustered indexes, but a very traditional type of approach there. Some of the larger dimension tables, there was one we went ahead and we partitioned that one. We had some with our traditional non-clustered indexes, and that other big one we also did a non-cluster column store indexes. And basically we made our decisions based on the knowledge from the Oracle DBAs about how these tables were going to be queried and used from their experience, and it turned out to be pretty good in the end. So testing. We thought it was very important to use consistent dates, so we used the exact same dates in each particular test on each system. And we returned the same number of rows each time across both systems. We chose those queries. They're big, ugly queries that were, you know, really, really long queries, and they had like multiple case statements in there. It's just a really ugly thing to look at. To show some really bad ones to get through. And we didn't officially test simple queries, but from just anecdotal evidence of the DBAs running queries, there was no issue with that. So, you know, just to say, hey, this is what we tested, some really ugly ones, and, you know, turned out pretty good. So we're getting near the results here. So let's talk about the contestants. Okay, so in this corner, Oracle 12c on 2 nodes of a 4-node rack, using 40 cores of 79 that were allocated across that configuration. And so it had 512 gigs of RAM to deal with. So that's more than twice what we had with both cores and memory. It had dedicated attached storage. They weren't running any ETL processes on the dev test environment. They didn't clear the cache out every time they ran a query. They didn't collect any other additional performance data. And basically the tables in each system, you know, the Oracle system and the SQL Server system, were exactly the same except for one table. And that was just because we didn't have enough space, you know, storage space, that was allocated to us to accommodate that. So we had to pick our dates carefully for the querying. But so the Oracle 12c one of the dimension tables had 3 billion rows. In SQL Server, we had 600 million rows. But we also set up ETL processes in SQL Server on our side to simulate loading data that's going to be happening constantly. We cleared the caches before every set of queries so that we wouldn't get a benefit of having a dirty cache, or warm cache, if you will. And again, we only had 16 virtual CPUs and 256 gigs of RAM, so they had more than double the stuff. We were on a VM. We had shared storage on a SAN that was being used by who knows what. So you know, this is kind of a setup for failure, if you ask me. But we weren't. We were very successful. And so we had 3 main queries that we ran. So how we want to read this is query A. We had a query covering 1 day, and in Oracle, that 1-day query took 85 seconds to run. The SQL Server system took only 7. Then we ran the same query for a 1-week period, and then a 2-week period, and a 1-month period, and a 3-month period. And as you can see, SQL Server won every single time on query A. Okay? Query B, same thing. 1 day, 1 week, 2 weeks, 1 month, 3 months. And every single time, SQL Server beat it. Matter of fact, a couple of those took over 9 minutes to run, and it took one second in SQL Server to get that same result. Query C, same thing, same story, except for the very last one. And I think that was an anomaly. We didn't have time to actually run the test again, or would have, to verify that that was correct data. So, but still, after all these, SQL Server really came through with that Columstore index, really showing its magic here. So it's incredible, the power of the Columstore setting. So after that was over, I got back home and started looking through additional data. I had some Perfmon data running and looked at it, and I said we could have been even faster because our CPU was only running at 20%. We didn't have any memory pressure, but we had some latency issues on the disk that we were using because it was a shared disk. Other people were using it. So we could have been even faster if we would have had a decent storage device, that was dedicated just for us. So in the end, we really, showed how powerful the Columstore index is. So what's going to happen next is the customer is going to perform a proof of concept with Microsoft at MTC, and there are some data architecture changes coming to the fact table, not because of this testing, but just because they're changing some stuff in their application, and it's going to require some changes to their fact table. So some of the work we did is going to have to be rethought out through before they implement it again. Also, we didn't do any index tuning. We just made decisions based on interviews with the Oracle DBAs. We didn't actually, go and have scientific data to make sure we were choosing the right things because we had a very limited time in order to execute this on. And we didn't look at the code. We didn't, other than changing like data types for some of the parameters and stuff, we didn't change any code in the stuff we tested. It was just, we didn't look at the query plans and figure out, what we could change to make it better. Again, we just didn't have the time to do that. That's some other things we could do to make it even faster. So that's pretty cool. Now, I did want to mention that their Oracle data warehouse was on an Oracle rack system for high availability. And so what can we do in SQL Server, to make that happen, if you will? So one of the main things in 2016 is with always-on availability groups, you can really scale this thing out. So in this scenario that we drew up, we have a primary with the data that's getting from all the plants, etc. And we have a synchronous secondary in the same data center for failover. And then we have async secondaries, and they can be at another data center, maybe even an Azure data center, but we can actually move that async secondary for reporting purposes closer to the plants, so that there's even less latency between the plant manager running the queries, etc., in order to get those results. So, and all of this is really possible because of all the really great work that the Microsoft team did on getting the indexes to, or removing a lot of the restrictions from the indexes so they can work well together. Yeah, I'm just really impressed with the results we got here. So, to summary here, SQL on a smaller VM beat Oracle on Big Iron in this particular test. SQL Server 2016 with Columstore indexes performs better than the Oracle system, even with their in-memory technology. We made efforts to try to hamper us as much as possible, having ETL and clearing out the cache all the time. And we didn't even get into the fine-tuning of anything. So but I really believe that this is going to be a serious competitor to anyone who's running Oracle, especially a data warehouse. This thing is just going to smoke, in my view. So, wow, that was hopefully a lot of data and useful information that I kind of just blurted out there for you. So I think I'm ready for some questions.
Okay, that is, okay, one question now here.
Okay.
Would the same result be achieved with SQL Server 2014?
So in this particular scenario, it would not, because we needed to have the real key, in my opinion, was the combination of the clustered Columstore index with a non-clustered Rowstore index on top of it, so that we could get much better seek performance after you read that row group in. You have that non-clustered index to get better seek performance on that, and also the Deltastore. Because if you don't have that, then you're probably still going to have good performance, but we got excellent performance because of that.
Okay. Yeah, looks like there's no more questions here. So.
Oh, wow.
Okay. No, one more. People.
Okay.
Yeah. Okay. Did you use bit? Yeah, they're just typing. So, did you use bitmap indexes on the Oracle side of the test?
So I do not know exactly what indexes were being implemented on the Oracle side, because I'm not an Oracle guy, so I wouldn't even know, what that was if it bit me. So and that's the other thing is that again, we had a very time box, very time box on what we could do, and so we weren't looking to make the Oracle system any faster, right? I mean, they were having issues. We're not Oracle experts that were brought in. We're SQL Server experts that were brought in, and migration experts, right? So we know what sort of things to look out for in order to get SQL Server to perform well. And I wish I could answer that question for you, but I really can't. I remember when I did this presentation at the Charlotte SQL Server user group just a couple weeks ago, we had some questions that were very much SQL or Oracle focused on, well, were they using this or using that? And so I don't have that data for you, but they have a team of Oracle DBAs, and I talked to one of the leads, and he could have been fooling me, but he seemed very knowledgeable about Oracle. So when I asked the questions, generally I got the answers I was expecting to get.
Okay. So next one here is how to handle index maintenance on clustered Columstore indexes, especially if no partitioning available.
So I am learning quite a lot as well. And I don't know the answer to that one because we didn't have that occasion to actually, we did this in a very short period of time. We weren't looking at that. However, I would point you to someone who probably has information about that, and I bet you probably already has a blog post about that. And Murilo knows who I'm talking about. That is, of course, Nico at nicoport.com.
Yeah,
correct, Murilo?
Yeah, nicoport.com.
Yep. Yeah, he has over 80, I think, blog posts about Columstore.
More, almost 100, I think. So yeah.
Wow.
He has everything there.
Yeah, and I want to give kudos out to Nico for his session earlier today. I missed it, but he has great resources on his website. I used his set of Columstore index queries to help me understand what was going on underneath the covers when we were first started to build the cluster Columstore indexes on top of the tables. And also his summit session from last year was just very helpful to me and getting up to speed and getting some other ideas on how to approach the situation with this customer. So I can't say enough about nicoport.com.
Yeah. Okay, so next one is, have you worked with SQL 2016 Fast Track Data Warehouse?
I have not yet. So I don't know if, I would imagine that the Columstore index has to be part of that, the recommendations there, because that's kind of the general recommendation now, is for your fact tables to, if not be a cluster Columstore index, at least have a Columstore non-cluster Columstore index on top of it, because of, again, the tremendous speed you get from all that compression that you have.
Okay. Next one. Do you recommend to drop and create the clustered Columstore indexes during ATL, or can we leave it open during ATL?
So from the experience that we had, again, we had a very limited time of, that we were working with this particular aspect of it. It looked like for this particular situation that we were going to leave it open and do a periodic reorg on maybe a weekly or bi-weekly basis, depending on the additional data we got, because we weren't having live data feeds into there, so I can't really tell you the answer to that one. For our experience, that is.
Okay, looks like this. I have the last one here. Is how often do we need to rebuild the indexes?
That is a good question, and I'm going to really point you back to Nico Port, because he has lots of blog posts, and I would say he probably has the answer there. In this particular scenario, where the customer is basically just adding data constantly, the rebuilding of the indexes would really just be on the newer segments of that data. So I would think that it really depends on your volume of data coming in and how often you would need to rebuild that segments. And you want to use partitioning so you can rebuild just that portion of the index, and not the whole thing. Because stuff that's older has already been compressed and not going to change in this scenario.
Okay, more. Okay, questions are popping up here again. Okay,
right.
it looks like clustered Columstore indexes is not supported when we have computed column in the table. Is that limitation going away? Do you know this?
I do not know if that limitation has been removed as of yet. I don't want to venture a guess on that, but this is basically the third iteration of Columstore indexes and the second one of the clustered Columstore index. So in each time they do an iteration, it gets better. They remove more obstacles. So I would guess that my guess is that it's probably still a restriction.
Okay. Okay, it looks like we are done now. Thank you, Rick, for your time here to share your knowledge to the community. We know this is very valuable for us, and yeah, I hope to see you again in the next event, and hope to see the audience in the next session that is starting. Temporal table and their role in the ATL and data warehouse, which is kind of related to this one.
Yes,
So,
yeah. And also just a shout out, if you want, there's another session coming up shortly by Martin Cathrall, again on Columstore indexes. That's, I forget what time slot it is, but it's coming up soon. So that might be a great place to learn even more about Columstore indexes. So thanks for joining. Thank you, Murilo, for being my moderator and hosting this event for me.
Oh, my pleasure. Okay, thank you everyone, and see you soon. Bye-bye.
Bye.